Right, this is going to be a real short video of how to add fractions with unlike denominators or subtract fractions with unlike denominators. So the first thing you want to do is you want to find the least common multiple of the denominators. This is the same thing as finding the least common denominator, just some books or some people might say LCM or LCD, so we mean the same thing here. The second thing you're going to do is you're going to make equivalent fractions with each fraction having the denominator as the least common multiple. After that, you're going to add or subtract the numerators and keep the denominator as the least common multiple. And then the last thing you're going to do is you're going to write your answer in lowest terms. So that means you're going to reduce if you can. So we'll do a couple examples, one with some fractions, maybe a couple with mixed numbers and some negatives, just to kind of get a feel for it. All right, we're going to take a look at an example fractions that have unlike denominators. So we have 3/8 plus 1/3. So I have something that's in eighths and I have something that's in thirds. So those aren't the same pieces. So if I have eighths and thirds, they're not the same pieces. We can't combine them. So we're going to have to find the least common multiple here. And one way to make this kind of easier is choose the larger of the denominators, which is the 8, and we will write multiples of the 8 and see which one the 3 might divide evenly into. So multiples of 8, 8, 16, and 24, and I might need to go a little bit further. So when I try to, we know 3 doesn't go into 8 evenly, and we can try, and 3 won't go into 16 either. So, but we do find that 3 does go into 24, so that's going to be the smallest multiple that is in common of both 8 and 24. I mean 8 and 3, excuse me, is 24. So what we want to do is we want to rewrite these in terms of 24ths, because that's what we can break them down into being the same. So if we break down 3 over 8, the common denominator here is 24. So I need to figure out what do I need to multiply the 8 by to make a 24, and it's 3. So with a fraction, if I multiply the denominator by 8, the bottom, not by 8, by 3, excuse me. If I multiply the denominator by 3, then I have to multiply the numerator by 3. So 8 times 3 is 24, and then for the numerator, 3 times 3 is 9. Now if I do the 1/3, I need to multiply 3 by 8 to get to 24. So I need to multiply the numerator by 8 also. So 1 times 8 is 8. Okay? So these are my equivalent fractions here, 9 over 24 and 8 over 24. So before we reduced those. 9 over 24 reduced to 3/8 and 8 over 24 reduced to 1/3. So we're kind of going backwards, but we're going backwards so we can combine these fractions. And then it turns into a problem we've done before. So we've added fractions with like denominators. You just add the numerators. So if we add these numerators here, 9 and 8 makes 17, and the denominator is 24. And so our steps were to find the LCM, which was 24, then make equivalent fractions, so we did that right here. And then we added or subtracted the numerators, so the 9 and the 8 made 17. And then and keeping the denominator as the LCM, which was 24. And then finally we write in lowest terms, which means can we simplify or reduce? We can't do that. Alright, we're going to look at an example where we subtract two fractions with unlike denominators. This time we have denominators of 10 and 15. So what I want to look at is the multiples of 15 and then see which one of them 10 will go into. And we're interested in the smallest one. So multiples of 15, 15, 30, and then if I went further it would be 45 and 60. But we're interested in dealing with smaller numbers, so it's 30. And I'm going to do this a little bit different than I did the last one. We're going to do it all in line as opposed to writing the equivalent fractions on a separate line. So in order to make a 10 into a 30, I need to multiply 10 by 30. So 9 over 10. Anything we do to the top of a fraction, we need to do to the bottom. So we're going to multiply 9 over 10 by 3 over 3. Notice that 3 over 3 is a quote-unquote flavor of 1, so that does not change it. It's still 9/10, it's just it looks different. Now 11/15, to make the 15 look like a 30, we need to double it or multiply it by 2. Okay, and multiplying fractions, it's nice, straight across, straight across. So we have 27 over 30 minus 22 over 30 after we did that multiplication. Now you must resist the temptation to reduce here because you see 22 over 30, they're both even. 27 over 30 are both divisible by 3. If we reduce here, then we go backwards and we get to the beginning of the problem instead of the end. Okay, so we have common denominators, so we're going to subtract the numerators. 27 minus 22 is 5. Denominator is 30, and then we can reduce. So they are both divisible by 5. So if we divide 5 by 5, we get 1. If we divide 30 by 5, we get 6. So we are left with 1/6. Okay, let's look at one more where they kind of just throw everything at us. They have fractions in both just a regular fraction like 2/3, and then they also have an improper fraction, and then of course we also have a whole number. And there's 3 of them, which is fine. We can do this. It's the same idea as before. So we want to find the least common multiple of the denominators, but hey, the 5 doesn't have a denominator. We'll be able to address that in a minute. To make it a little bit easier, though, I would suggest that we convert the mixed number, which is 2 4/5, into an improper fraction. So what I'm going to do here is I'm just going to rewrite. So it's going to be 5 minus, and to convert into a improper fraction, we have 2 times 5, which is 10, plus 4. So that gives me 14 over 5, and then plus the 2/3. Okay. Now there's an issue with the 5 there. It doesn't have a denominator. Well, we can make any whole number, any integer, into a fraction by having a denominator of 1. So what I'd like to do is I'd like to find the LCM of 1, 5, and 3. 1's going to go into anything. 5 is the biggest here, so we're going to look at multiples of 5. So 5, 10, 15, 20, 25, etc. But we're looking for the smallest one that the 3 goes into. So 3 doesn't go into 5 evenly. It doesn't go into 10 evenly. However, it does go into 15 evenly. So that's our least common multiple. So what we would like to do is we would like to have each denominator look like 15. So if I'm going to do the 5 over 1, how do I change a 1 into a 15 with multiplication? I have to multiply it by 15. So we're going to multiply the numerator and the denominator, the top and the bottom, by 15. Okay, minus, and then we have the 14/5, and to change the 5 into a 15 with multiplication, we need to multiply by 3 over 3. And finally, the 2/3. We need to multiply it by 5. 3 times 5 is 15, so 5 over 5. Okay. And then we'll multiply straight across. So 5 times 15 is 75. 1 times 15 is 15. Then we're going to have the minus sign there. 14 times 3 is going to be 42. Divided by 15 plus 10 over 15. Okay. Now you can do this next part in all one step and subtract 42 from 75 and add 10 all in one step, but I'm going to do it in 2 steps here. So if you follow order of operations, you do addition and subtraction in order from left to right. Everybody's got a common denominator, so we're good there. So we can subtract here first. Because the subtraction comes first, we do the subtraction. So 75 minus 42, I believe, is 33 over the denominator, plus 10 over 15. Okay, common denominator, add the numerators, and we have 43 over 15. Now, depending on the situation, depending on what the problem's asking, they may let it be an improper fraction where the numerator is larger than the denominator. Or they might want it as a mixed number. And where we might want it as a mixed number is some sort of application. 43 over 15 miles isn't real meaningful to us. So what we want to do is convert it into a mixed number. So 15 goes into 43 twice. So 15 times 2 is 30. And then 13 gives added to the 30 gives us 43. Okay, so 2 and 13 over 15 is a little bit more meaningful for us if we were talking about an application. Again, it depends on the problem, but either one of these answers is probably fine depending on the instructions.